This is Honors Geometry, Lesson 11.6, Area of Regular Polygons. So if you were asked to find the area of a polygon and you didn't have a formula, what you would probably do is chop it into shapes that you do know. For example, our regular pentagon, maybe you see that it's a triangle and a trapezoid. Or maybe the hexagon is two trapezoids put together. Or maybe an octagon is a rectangle and two trapezoids. Okay. But there's one shape that works for all of our regular polygons, and you can probably guess what that is. That's our good old triangle. If you would slice up our polygons like you would slice a pizza, we could find the area of one of these slices, and then we would just multiply it by the number of sides we have, or number of slices. So in order to find the area of one triangle, we would need two things. The area of a triangle is 1/2 base times height. So we would need the base of the triangle, and we know the base of the triangle really is the length of our side. And then we would need the height of the triangle. And the height of a triangle is something called the apothem or apothem. And the way they get that is what they do is they circumscribe a circle about the polygon. And it's the length of a segment from the center of that circle to the side, perpendicular to the side of the polygon. So we call that a apothem. And then all we do is multiply those triangles times the number of sides. This one I sliced into 5 equal triangles. So I would multiply that times the number of sides. So that's the formula we're going to use. It's 1/2 ASN. We're just going to find the area of each triangle and multiply it times the number of triangles. So the first thing they say is that in order to get that center to slice up that polygon, we inscribe the polygon in a circle. And those slices are actually the radii of the circle. You can see that. And we said, in order to get the central angle, we're going to need the central angle in order to do some calculations. So I sliced this one into 5 equal slices. We know that a circle has 360 degrees. If you divide that 5 equal ways, if you take 360 and divide it by 5, you would see that each central angle is 72 degrees. On this one, it's a hexagon, so we took that 360, that full circle, and we divided it 6 equal ways. So you would see that each central angle is 60 degrees, and we're going to use that in a couple minutes. So that's what it's saying here. To find the measure of each central angle, divide 360 by the number of sides. Okay, and here's the formula we're going to use. 1/2 ASN. A, remember, is the height of the triangle. We call that the apothem or apothem. S is the length of the side of our polygon, which is the base of our triangle, and N is the number of sides. If you take the length of the side times the number of side of any polygon, of course that would be the perimeter. Okay, so you can find the perimeter of the polygon and then use that instead. All right. First thing we're going to practice is how to find the central angle. So in this case, we have 10 equal parts. So we're going to slice it up into 10 parts. And you don't have to diagram this. All you're going to do is you're going to take your 360, your full circle, and you're going to divide it 10 equal ways. So you can see each central angle is 36 degrees. This one, it's cut up 18 ways. So you take 360 divided by 18. And you can see each central angle is going to be 20 degrees. Let's go ahead and practice. All right, so find the area of each regular polygon. So we know the formula is area equals 1/2 ASN. And so I substitute what I know. They give us the apothem. You know it's the apothem because of this right angle symbol. That's the height of our triangle. So they're giving us that the apothem is 14.5. The length of the side is right here. That's 12. And N stands for the number of sides. And this is an octagon, so that's 8. So we're going to punch that in our calculator. And we could see the area of this polygon is 696 square units. You know it's not going to be that easy every time. We're going to start taking some of that information away from you. So the first thing I like to do is write my formula. So I have area equals 1/2 ASN, and then I substitute what I know in. This time we're not given the apothem. We're going to have to calculate that. Length of the side, that time we are given. We have to be given something. And N, it looks like a hexagon, so we're going to put 6 in for the number of sides. So the only thing we're missing this time is our A. So we're going to use that trick to find the central angle. We're going to take 360, divide it by 6, because this has 6 sides. It's cut 6 equal ways. And we see that each central angle is 60 degrees. When we drop that apothem, it's going to split that 60 into 2 30s. Because these radii are congruent, it's an isosceles triangle, we can assume that it's cut into equal parts. It also splits that 9 in half, so each of those would be 4.5. You maybe recognize this is a 30, 60, 90 triangle. Certainly you can use that. If it's not a 30, 60, 90 triangle, we're going to use trig. So with your choice. So I'm looking for, from the 30-degree angle, I'm looking for adjacent, and I'm giving opposite. We don't have the hypotenuse, we don't need the hypotenuse. If you look back to SOHCAHTOA, opposite adjacent tells us we're going to use tangent. So we say tangent of a 30-degree angle is equal to opposite, which is our 4.5, over our adjacent, which is what we're looking for. We're going to cross multiply. I want A by itself, so I'm going to divide each side by tangent of 30. And again, if you wanted to use your special right triangles, there's nothing wrong with that. So I'm going to take 4.5 divided by tangent of 30. And I get it's about 7.79. So I'm going to go ahead and put that in my formula. And we're going to calculate that. 1/2 times 7.79 times 9 times 6. And we can see the area of this regular hexagon with a side length of 9 inches is 210.33 square inches. All right, let's try one more. I'm going to take away some more information this time. All right, so again, what I start with is I start with the formula and I substitute everything I know. So area is 1/2 ASN. S is the side length, N is the number of sides, A is the height of the triangle, the apothem. All right. So A. In order for us to have A, you have to look for that right angle symbol. It has to be perpendicular to the side. It has to be the height of our triangle. You can see this isn't the height of our triangle. That's actually the radius of the circle that's circumscribing this polygon. So that's not our A. So we're not putting that in the formula. The length of the side, we're not given. And the number of sides, we have a pentagon, so we know that's 5. Okay, so we have a little bit of work to do here. So again, the first thing we're going to do is take 360, divide it by the number of sides we have, which is 5, and we're going to see that each angle is 72 degrees. Each central angle is 72 degrees. We're going to take that 72, and when we drop that apothem, it's going to split that 72 into 2 36s. So we need two things. We need opposite and we need adjacent because we're missing 2 parts of our formula. So if we look for opposite, that's our side length. Opposite hypotenuse, if we go back to SOHCAHTOA, opposite hypotenuse is sine. So we're going to say sine of a 36-degree angle is opposite, I'll just call it our S, over hypotenuse, which is 4. Cross multiply. And we have sine of 36 times 4. is 2.35. So I know that this equals 2.35, but just be careful. Remember, that's only here. That's just the opposite from the 35. I need the whole thing in order to be my side length. So don't forget to double that, okay? So I'm going to multiply that by 2, and I get 4.7. So now we have our S, our 4.7. If you wanted to at this point, you could certainly do Pythagorean theorem using the 2.35. I'm just going to stick with trig. Now we're looking for adjacent, and we have hypotenuse. Adjacent hypotenuse tells us we use cosine. So I'm going to say cosine of a 36-degree angle equals adjacent over the hypotenuse, which is 4, we're given. Cross multiply. So I'm going to take cosine of 36 times 4, and it's about 3.2. And that's the height of our triangle, or A in this case. So now we have everything we need by using trig and the central angle. So I'm going to punch that in my calculator. 1/2 times 3.2 times 4.7 times 5. And I could see that the area of my triangle is 37.6 square inches. All right. Please try the practice problems. Let me know if you have any questions. Thank you.